In this video, we are doing question number 24, that is from exercise 8.2. The question says that show that the sum of the ratio of sum of first n terms to the of a GP to the sum of first n plus 1th term to 2nth term is 1 over r. Well, we are going to use this formula, and that is the general formula finding sum of first n terms, that is Sn is equal to a r raised to the power n minus 1 over r minus 1. So let me first write down the GP here. That has to be the A being the first term, AR second, AR square, AR raised to the power cube, AR raised to the power 4, so on. And the nth term in between, there will be a term because we have to get till 2nth term. So 2nth term will be what? R raised to the power 2n minus 1, right? As you know that nth term is AR raised to the power n minus 1. So 2nth term will be what? AR raised to the power 2n minus 1. So in between there must be a term, that is nth term, because we are getting till the 2nth term. So this should be AR raised to the power n minus 1. Obviously, the next term going to be AR raised to the power n. It is important to understand that this is nth term, right? Not n minus 1th term. And this is the next term. So nth term is always represented by AR raised to the power n minus 1. Well, if you read the question once again, you will find that we have to show that, we have to show here that the sum of terms, first, the ratio of nth term. The nth term is still here, as you can see, nth term is still here. All right. And the term from n plus 1th term. So n plus 1th term start from here till this, right? In between there are terms, right? In between there are other terms. So we have to find the ratio of these two as 1 over r raised to the power n. So let's first find out the sum of first nth term using this formula. That's going to be a is a over here, r is replaced by r only raised to the power n minus 1 over r minus 1, and that divided by this, right? As you know, it won't be, we cannot find the sum of the term arising from ar raised to the power n till this. So for that, what we are going to do, we are going to find the sum of terms from here to here, and from which we'll be subtracting this sum, right? This sum. That will give us the sum of this terms from n plus 1th term to 2nth term. So that means from the whole, we have, I mean to say that I'm getting the sum from here till here for this a being a and r being r only. R is r only. Well, n is 2n. As you can see, we are getting till the 2nth term. So n is 2n minus 1 over r minus 1, from which we'll subtract this green portion, we will subtract this green portion, that is the nth term. So it's going to be, that is a r raised to the power n minus 1. This is n on the base minus 1 r minus 1. We can simplify it further. As you can see in the new denominator, we can take something common, that is, I'll just show you. This is a r raised to the power n minus 1 upon r minus 1. I can see we have a and r minus 1 as common, so we'll take it out. That is a over r minus 1. Inside we'll be left with r raised to the power 2n minus 1 minus r raised to the power n minus 1. And this is minus 1. Now, as you can see, this part get cancelled. Here, this get cancelled. So what is left in the numerator is r raised to the power n minus 1. And the denominator, one mistake we did, right? While opening the bracket, this minus sign will open, will influence this sign, will become positive. So here again, minus 1 plus 1 get cancelled. So we are left with r raised to the power 2n, r raised to the power 2n minus 1. That's what you got. Now, oh, that's r raised to the power n, sorry. This is r raised to the power n. Now further you can see that we can further simplify it. If I take r raised to the power n common from the numerator, we'll be left with r raised to the power n minus 1. Now this also get cancelled. So this and this get cancelled. So we are left with 1 over, is left with this only, that is 1 over r raised to the power n. And that is what we were required to prove, right? This is what we were required to prove.